Alright, sorry, I ran out of videotape room and had to delete some videos. Kind of lost my train of thought. Let me see if I can jump back into it. So basically, you get enough malformed cells sticking together, we start to call that cancer. Now, each one of those cells may have reproduced rapidly and produced the cell next to it, or it may have um, been an environmental uh, co-founder of the tumor, and quite frankly, that's why they're seeing a lot of genetic diversity when they're cutting open these cells, because it is a multifactorial um, growth. There are many factors involved. It's not one cell that reproduces rapidly over and over again, and all the cells around it are a byproduct of it. Although I'm sure there's the exception to that. Um, the majority of the cancer clusters that are single celled would be well handled by your natural immunity, I would imagine. If there are environmental cofactors, your immune system may be inhibited. So, I mentioned that hydrogen is responsible for binding these uh, nucleic acids together, and I believe that's true. Um, it is the glue that binds, but isn't that a bad thing? Because that's what caused the DNA to recombine in a malformed way. And the answer, I would say, is yes and no. While in the complete absence of hydrogen, the DNA wouldn't recombine at all, and it would, die from the initial break. I don't think you would survive either. And the fact of the matter is that the hydrogen isn't just responsible for making the direct bonds in your DNA, it's also reacting with catalysts and very aggressive um, reactive oxygen species. And those reactions are happening most importantly for the topic in the mitochondria. And if enough of those reactions can happen in the mitochondria of a damaged cell, a cancer cell, then it creates energy, right? And that energy is metabolism. It's important to understand. The word metabolism, when I learned this, something clicked. And I'm not trying to take ownership of it. It's just when I learned it, it clicked. Metabolism only means energy that's produced in your body that serves a useful function. That's it. It doesn't have to be produced by your mitochondria. It doesn't have to be produced inside the cell. It can be produced extracellular. And as long as it has a function, it is considered part of the metabolism. And trying to trace all those reactions, those energetic reactions that happen in your body, is a specialty in medicine that I think is respectable and extremely complex. But to simplify it in my monkey mind, when you introduce a fuel that is reacting inside a damaged cell, that damaged cell is going to create more energy, and that energy is going to cause expansion of the cell, and expansion of the cell can cause a damaged cell to rupture. And that is the objective when you are trying to treat cancer. There are second order effects that I've come to understand that are equally as beneficial. So you can look at that metabolic induced apoptosis as a short-term cancer therapy, and I believe that happens. But a long-term cancer therapy, by the same mechanism, by the same protocol, is the flushing of the mitochondria and the interruption of the Warburg metabolic cycle. And that is basically restoring the mitochondria's functionality to again induce apoptosis, but slower, because that flushing out would take multiple exposures over long periods of time. But each one of those represent a high dose and low dose scenario that are seemingly equally beneficial. I just don't see a reason not to do it. Now, this is where it gets even more compelling. Even more. The standard of care for the longest period of time has been, burn it out. Radiation therapy, chemotherapy, bring you to the point of death so that fast reproducing cells are exposed to death, extreme conditions, extreme environmental conditions, and those fast reproducing cells die because they're fast reproducing, so their offspring are young, their offspring are exposed to rough environmental conditions, and their offspring don't produce. Ergo, the rate of the tumor growth is reduced. And that is all based on inducing stress, right? You want to induce stress in order to kill the young, quickly reproducing cells. But when they apply hydrogen therapy to people who are receiving this stress-inducing therapy that is designed to kill based on high levels of stress, and then simultaneously provide this stress-alleviating therapy, which reacts with highly aggressive, it's radioprotective. We're giving radiation and radioprotective therapy at the same time. They would be conflicting, but the benefits improve. So the question becomes, and I've mentioned this before, I know it, but it's worth repeating, is the hydrogen therapy overpowering, not just working in conjunction with, but actually overpowering the stress-induced cancer therapy? And I think that's a worthy question. I think about sums it up.